The second compound data construct we're going to introduce is called a list. And a list looks a lot like a tuple, but it has one key difference. Again, it's an ordered sequence of information accessible by an index. And I'll remind you, ordered means not that they are in ascending order, but rather they're ordered so that I can say, give me the 0th, the 7th, the 9th element. They're denoted a little differently. They're denoted with square brackets to tell us that this is a list, not a tuple. They can also contain elements. Usually they're homogeneous. All integers, all strings, all tuples of integers or strings. But we can, in fact, have mixed types in them. But the big difference is that lists can be changed. So a list is mutable. And that means that I can go in and change the element of a list to be something different. Very different from a tuple or a string. We said those were immutable. I could not change portions inside of them. I can with lists. And we're going to see that that's both really useful and can provide some real problems or cause some challenges because it opens up opportunities for making mistakes that we don't expect. With lists, again, I've got the same kind of idea that I have an element at a particular index or position. I start at 0 as I've done before. So I can create a variable name. I can bind it to an empty list, much as we would do before. And I can index elements of a list starting at 0. So the examples I show here are things you would expect for any kind of construct like this. I can ask for the length of a list. We've used len before. I can get out the 0th element. I can get out an element and do something to it, like adding 1 to it. And if I try and go beyond the end of the list, I'm going to get an index error. So this has got things at 0, 1, and 2 indices, nothing at 3, and so this will give me an error saying I'm trying to go too far beyond the end of the list. An index can also be an expression or a variable. It doesn't have to just be an integer. It could be a value. So for example, if I bind I to 2, and then I ask for the element at I minus 1, since I is 2, I minus 1 is 1, and L of I minus 1 gives me out that element right there out of the list. And we're going to see that's handy as we want to think about how to use expressions to tell us where to look inside a list to pull out a value. As I said, lists are mutable. And so one of the things we want to look at here is how do we do it, and then what's going to be the implication of that. In particular, if I have a list like the one shown here, 213, I can now evaluate this expression. It says, take the first element, or the element at index 1, and change it to be 5. And that will literally change L itself. It does not produce a new list. It changes the same object. So this is different from strings and tuples, an important distinction. And one way to think about it is when I first bound L, it pointed to that structure, that list in memory somewhere. When I evaluate the second expression, it literally changes that middle element. But L is still pointing to the same expression. A lot of advantages to this, but some real challenges. And that's what we're going to look at next. Before we do it, one last piece. Just as I can iterate over tuples, I can iterate over lists. They are also iterable. And so a common pattern would be to, for example, walk down a list and add up all the elements if there are a bunch of integers. I could certainly do that the traditional way. Here I'm running through a for loop that's going over the range of possible indices. So length, or ln of L, gives me the number of elements in a list. Range will give me something that gives me everything from 0 up to but 1 less than the overall length of the list. And I could simply add things up. Standard way of doing it. Much cleaner is to recognize that I can simply iterate over the elements of the list themselves. So that loop says, let I take the first element of the list, then the second element of the list, and so on, and simply add those together. And this creates cleaner code that makes it easier to see what I'm actually doing here. So lists are iterable, the same way that strings and tuples are iterable. A great property to have.